So in chapter 3, we're going to be talking about sequences and series. Maybe you remember that from Algebra 2, maybe you didn't, depending on your Algebra 2 class and how far they got. Something you might have talked about there. I'm going to operate as if probably most of us haven't heard these terms before. Everybody's okay with that plan? Okay. So a series or a sequence, that's what we're going to be talking about today, are sequences. A sequence is just a function, right? So this is a special kind of function, a sequence. The domain for our sequence is going to be positive or non-negative integers. So the only inputs that you can have into a function are positive, whole numbers, and maybe also 0. The outputs, though, can be any real number. Everybody's okay with that? So we traditionally will use a function notation. So like if I say f is the name of our sequence, f of 1 equals 1 means that 1, the output, is the first number in our sequence. If I say f of 2 is equal to 3, that means 3 is the second number in the sequence. F of 3 equals 5 means 5 is the third number in our sequence. Everybody's okay with that? So the input is like the term number, and the output is like the term value. So sometimes we'll use like the traditional function notation to represent a sequence, and sometimes we'll use a subscript. So like f subscript n means the same thing as like f of n, where n is just like our independent variable. Oftentimes we'll refer to that subscript as the index, and unless it's stated, we assume our index starts at 1. So sometimes it might be 0 depending on the context, but I think for this class and this textbook and the IB in general, they have everything starting with 1. So an example for a sequence might be the set of values 1, 1/4, 1/9, 1/16, and 1/25. What that means is that since the first term is 1, f subscript 1 is equal to 1. Since the second term is 1/4, f subscript 2 is equal to 1/4. Since the third term is 1/9, f subscript 3 is equal to 1/9, etc., etc. Is everybody okay with how we kind of did that? And again, these values, 1/4, or 1, 1/4, 1/9, 1/16, 1/25, those are called the terms of the sequence. So like 1/9 is the third term in the sequence. So the subscript tells you the term number, and the value is like the term value. Is everybody okay with like the vocabulary and the notation here? Really important that you understand that, because as we continue moving on, like we're going to use this language and symbols and notation exclusively here. So it's important that like you understand what stuff means. All right. So some more examples of sequences. Maybe you have the sequence 6, 12, 18, 24, 30. If I look at this sequence, what is the pattern that you see happening in this sequence? We're going up by 6 each time, right? Everybody see that? What if we look at this next sequence, 3, 9, 27, ... 3 to the k, comma, ... What's going on here? What's the pattern here?
So you're going up by an exponent each time?
Yeah, you're multiplying by 3 each time, right?
Oh, yeah.
Like 3 times 3 is 3 to the 9th. 9 times 3 is 27th. Did I say 3 to the 9th? I didn't. I meant just 9, right?
Yeah.
Or you could think about this as 3 to the first, 3 to the second, 3 to the third, right? So this second sequence and this first sequence are fundamentally different, right? How many terms are in this first sequence? 5, right? Because you see that it stops after 30. How many terms are in this second sequence?
3.
See the dot, dot, dot?
Oh, okay.
Infinitely many. So the first sequence we'd call a finite sequence, and the second sequence we'd call an infinite sequence. Everybody's okay with that? So some more ways that we can write a sequence. We can give you like the formula for a general term of the sequence. And then we can tell you the values that we're plugging in. So this sequence is generated by 1 over I squared, where I is going to be the numbers 1 through 10. So for example, the first term would be 1 over 1 squared, or just 1. The second term would be 1 over 2 squared, or 1/4. Then the third term, 1 over 3 squared, or 1/9, yada, yada, yada. Everybody's okay with that? And then you could just be like really opaque and vague and not really tell us much about the sequence at all. So B1, B2, da da da, Bn, da da da. That's a sequence, right? We don't really know much about it. What's the pattern going on there? Who the heck knows? What is B? I don't know. But it's just like, this is just n terms of a sequence, right? It's infinitely long, see the dot, dot, dot? Whatever. So let's look at a couple of examples. Find the first 5 terms and then the 50th term for this sequence Bn, where Bn is equal to 2 minus 1 over n. So how do I write symbolically the first term? I just do write B subscript 1, and then how do I find that? 2 minus 1 over 1, so just 1, right? How about the second term then?
2 minus 1 over 2.
Yep. And you guys get the idea after this, right? Okay. What if I want the 50th term? Right? Everybody feel okay? Whatever. You guys ready to whatever? I whatever that. All right. So a sequence is just like an ordered set of real numbers, right? It's a function from the positive integers onto the real numbers. Because it's going from the positive integers onto the real numbers, we can say they're ordered because the inputs are just the numbers 1, 2, 3, 4, 5, so we can order them by first term, second term, third term by the input. So when we have a formula like this, that's called like an explicit definition of a sequence. Oftentimes we're going to be interested in taking, here's some terms of a sequence, find the explicit definition. So our next example says, find the first 5 terms and then the 20th term of the sequence given at the opening. So remember the opening, the sequence terms are 1, 3, 5. What's going to be the 4th term? 7, great. And what's going to be the 5th term? 9. Everybody see the pattern going on there? Not too big of a deal. What if I want the 20th term? One way I could do it is I could keep listing them, right? I could just brute force this and just I know I can see what the pattern is. It's not hard to generate the terms. I can just keep going until I've done 20 of these things. What I would rather do, though, is come up with an explicit definition and then plug 20 into that. That might end up being easier, especially if it asks for, like, what is the 10,000th term of the sequence, which, like Yuckaruskis, I'm not going to write down, 10,000 of these things to find that. All right, so let's look at the pattern here. What's going on? Going up by 2. So the change between terms is constant, right? That's the observation that I want to make, right? Everything is plus 2. What does that remind you of? What if we just pretended this was like a function and we plotted this, where I have n and then f of n. So I have like 1, 1, and then I have 2, 3, and then I have 3, 5. It's not exponential. Looks like a straight line, right? It's going to be linear. So we're going 1 over and then 2 up each time, right? What does that look like to you guys? Equation of a line, right? What does that plus 2 look like to you guys?
Slope.
Yeah, it looks like slope to me. What do you guys think? Can you see the equation for a line yet? And then plus 1? Minus 1, right? If I plug 1 in, I should be getting 1 back, right? So I'd have to subtract 1, right? 2 times 1 is 2. If I add 1, I'd have 3. Rut-row-raggy, that's the wrong spot. I should be subtracting 1. We'll look at doing that more systematically here in the next section. But it's okay, right? So 39 is the 20th term. All right, let's look at another example of how we can kind of use a sequence. So a 180-liter bathtub contains 50 liters of water and is being filled at a rate of 10 liters per minute. How much water is in the bathtub after 5 minutes? Well, let's take this and try to write that as a explicit formula. I'm going to say B sub n is going to be like the water in my bathtub. So we start with 50, right? Everybody go agree with that? Rate of 10 liters per minute. When you hear rate, you should think slope. Does that look good to you guys? So after 5 minutes, we should have 100 liters, right? When will the water flow over the top of the bathtub? So we want, when will B of n be greater than 180? Everybody agree with that? Can you guys see what it's going to be right now? Yeah, 13, right? So I subtract 50 from both sides and I divide by 10. Oops. need to spin that around. Everybody agree? Okay. It says the drain is open when the bathtub contains 50 liters of water. It is still being filled at a rate of 10 liters per minute, but the water drains out at a rate of 15 liters per minute. How long will it take for the bathtub to empty? I should probably give that a new name. So still the same setup, right? But now we're losing water. And we want that equal to 0, right? What's n going to be? What do you guys think? Fairly easy still, right? Not a big deal. Okay. So moving forward, there are two special kinds of sequences that we're going to be talking about. The first one is arithmetic. When you hear arithmetic sequence, you should think equation for a line. And we're going to do everything involving arithmetic sequences the same way we would deal with equations for a line. So, blah, 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 blah. Our explicit definition is this. A sub n equals a1 plus n minus 1 times d. But all that is the point slope equation for a line just kind of rearranged and the labels changed. So you don't even really need to use that. You can do whatever. So it says find the nth and the 50th term of the sequence. So when I see this, I'm going to think about, hey, I have the point 1, 2, and I have the point 2, 11. Oops. First thing I'm going to do is check that it's arithmetic, though. That's a good idea. So to do that, I'm just going to check that everything is going up by constant rate. Everything goes up by 9, right? That's my D, or if you want to think about it as a slope, that's your slope. And I have, say, this guy be the point 1, 2. 1 because it's the first term in my sequence. So if I plug this into my point slope equation for a line, I'd have y. But instead of y, we're going to write as a sub n minus a1, which is 2, equals m, which is d. And then x, which we're using n in place, is equal to the term number, which in this case is 1. Or if I add everything over and distribute the 9, I have that. So a sub 50 is going to be 443 when I plug that in.
Is A of n just y?
A of n is our y, yes. Yeah. Yep. That's the name for our sequence. So it's a y, right? Because the terms in our sequence are kind of n comma a sub n, right? Or I'll use k. So there's 1, comma 2, term number, comma term value. Does everybody feel okay there? No big deal, right? Just like chapter 2 was. Part A here says find the explicit form of the definition of the sequence, yada, yada, yada. First thing I'm going to do is check to see if it's arithmetic. Here I notice I'm subtracting each time, but that's okay. That's still like adding a -5 or subtracting 5, same difference, still my D. So A sub n should be the first term minus D times n minus 1. So that's going to be 5n plus 8. And if I want the 25th, it's like 133 or something. Is this okay? So in these previous examples, we've always been given the first term to kind of deal with this, right? So again, first term, but this time we're not given the second term, we're given the fifth term. Again, I'm going to think about that as like 2 points. 1 comma 5 for the first term is 5, and then 5 comma 11 for the fifth term is 11. What am I going to do with those 2 points? If I want to write the equation for a line, I need slope so that's 3 over 2. And that's really all I need, right? Because I know from there it's going to be the first term plus the D times n minus 1. So what's that going to be? 3 over 2n plus 7 halves. What do you guys think? So far, so good? All right. So another application, a way we can use a sequence to kind of deal with the story problem. Susie decides to deposit an initial amount of 1,200, I think those are pounds, or no, euros, in a savings account on January 1st. The account pays 5% simple interest on the initial amount of money. Assuming she does not deposit or withdraw any money, how much money will the account have at the end of 10 years? When we say simple interest, what does that mean? Oops, I highlighted the wrong thing. Simple interest means it's only being paid on the initial deposit. You're not earning interest on the account value each year, so it's not compound interest. It's only being earned on the 1,200 euros that we had deposited initially. Everybody's okay there? Okay. So if we think about this as a sequence, what is the initial value? So we have to be a little bit careful here, right? Because at the end of year 1 is one thing, but what I would think about this as really is, I'd think like A sub 0 is 1,200. You guys buy that? That to me makes more sense to think about it that way. So I'm going to do then A sub 0 plus D times n minus 0. You guys buy that? So 1,200 plus Well, what's D going to be? We didn't spell that out, right? Should be that, right? Which is like $60. So A of 10 should be $1,800. What do you guys say to that? It's okay? So here, we're given the 50th, 51st, and 52nd term, but asked to find the first term. So remember, we have this formula, right? Everybody agree? And I can find the D really easily. What's the D? Yeah. So what I'm going to do is I'm going to say take this as my A sub n. A sub 1 is what we're looking for. D is 5. And then n should be 50. And in fact, let's make our lives easier. Why would I do that? Why not pick? Let's do that one. Why would I pick that one to make my life easier? 50 minus 1 makes the times 5 is a heck of a lot easier than 49 times 5, right? So if I do that, I get 250, and I subtract it over. That should be negative 239. You guys okay there? Again, what I did before was fine, but like I was doing this with no calculator, just didn't want to try to not screw that up. Okay. The other type of sequence that we're going to talk about is the geometric sequence. Take a look at that series of numbers, 7, 14, 28, 56, 112, 224. What's the pattern going on there? Yeah, multiplying by 2, right? So if the operation is multiplication, that's geometric. When you think about a geometric sequence and we graph that, what's it going to look like? Exponential, yeah. So that's what, when we hear geometric sequence, you think exponential function. Everybody's okay? All right. So the explicit formula could be written as u sub n equals u sub 1 times r to the n minus 1. R is that common ratio. Keep in mind, though, with that common ratio, you have to be a little bit careful. Look at, say, this sequence down here. What's the pattern going on? We want to think about it always as multiplication, so times negative 1/2. That's the same thing as dividing by negative 2. But if you start thinking about it as division problems, you end up screwing up your R. So I always want to think about it as a multiplication. Everybody's okay? All right. Let's go do some examples then. Yes, sir. So it says, find the geometric sequence where the first term is 2 and the common ratio is 3. Well, yo, Mr. Kulik, isn't all I have to do that? I think so. That'll do to me. Everybody's okay there with what I plugged in? It says, describe the sequence there. So what's the common ratio for part B? -4. What's the first term? I think that's probably what they're looking for. I don't know, or you could say it's a geometric sequence with common ratio of -4 and first term of 3. That would, I don't know if they're looking for words or symbols. I didn't remember. I didn't look at it very closely how they answered it. It's like, I don't do all this stuff. If I look at the next sequence, what do we see going on there? Yeah, so the first term is 1, the r is 1/2. Now notice that since that first term is just 1, we could do this, right? All right. And then it says graph the sequence. So I don't want to do that. What's it going to look like? So we have like 1 and then 3, or 1 and 1/4. And we'll have like 2 and 3/4, and then we'll have like 3 and 9/4, and then 4 and 27/4, and just, you know, everybody's okay? We're just plotting points. Should we ever connect the points for a sequence if we're graphing it?
No.
Never connect the points, because there are no you can't plug like a half in for n. That's not allowed. You can only plug in positive whole numbers. So when you graph a sequence, it's always just dots, never connected. Everybody's good? Find the 10th term of this geometric sequence. Well, I have that as my general. Everybody good with how I got to there? Now I could simplify that to just this. How do I do that? Two is 2 to the first, right? When I multiply things with the same base, I add their exponents. 1 plus n minus 1 is n. So that's how it just turned into 2 to the n. Don't have to do that. So the 10th term is just going to be 2 to the 10th, which is 1024. Computer people, is that right? Yeah. Okay. All right. So another example of place where we can use a geometric sequence to solve a problem. So at 8 a.m., 1,000 milligrams of medicine is administered to a patient. At the end of each hour, the amount of medicine is 60% of that present at the beginning of the hour. What portion of the medicine remains in the patient's body at 12 noon if no additional medicine has been given? So I'm going to think about U of 0 is 1,000, right? So we took some medicine. The R is 0.6 because we're decreasing by that much per hour, right? So my U sub n is going to be 1,000 times 0.6 to the n. Notice because we're using the 0th term, this is like -0 up there instead of -1. Is that okay? So we're starting at 8 a.m. So noon is how many hours? And at that point, it's calculator time for me. I don't know what that is. Everybody feels okay, though? With how I set that guy up? What's up? Okay. A second dose of 1,000 milligrams is administered at 10 a.m. What is the total amount of medication in the patient's body at 12 noon? Well, so probably do U2 to get us to 10 a.m. And then to go from 10 a.m. to noon, then we're going to do U2 plus 1,000, 0.6 to the second. What do you guys buy that? This is typically why medication you have to take like every 6 hours or 8 hours or whatever hours. Your body's going to be filtering that medicine out of your blood. So to get the medicine level back up to a normal amount, you got to take some more. All right. The other common application for a geometric formula is if you're looking at compound interest. So if you have compound interest annually, we usually write it that way. Or if it's like compounded, instead of compounded annually, if it's compounded quarterly or monthly or daily or whatever, the N changes. This is all stuff we did in Algebra 2, right? You guys recognize this kind of problem? I think everybody does these. Or even in trig and pre-calc, I think we do this stuff also, right? All right, so it says $1,000 is invested into an account paying compound interest at a rate of 6%. Calculate the amount of money in the account after 10 years when it is compounded annually, quarterly, monthly. Okay. So my principal, my capital P is 1,000. My N for each situation is either 1, 4, or 12. And then my interest rate needs to be my percent as a decimal, though. Has to be a decimal. So again, just kind of grinding that out, right? Everybody's okay with what I did? I don't have to type this into the calculator. You guys are good with getting stuff in your calculator, I hope. This is not tricky to type in. So here it says you invest $1,000 at 6% compounded quarterly. So PRN. It asks how long, that's the T, will it take for this investment to increase to $2,000? Everybody's okay with that idea? So we can do this the dumb way. I don't want to say the dumb way. You can do it the brute force way. I shouldn't say dumb. So I can type in the right-hand side into like my y equals. Right? And if I press second and graph, it'll give me a table of values. And I can just scroll down and see when does it tip over. So I would say after year 11 or something. Is everybody okay with how I did that? If I wanted to do this algebraically, though, I could also do this to solve for t. In doing so, what would I need to use? I'll end up needing to use a logarithm. So my first step would be divide both sides by 1,000. And then to get that exponent by itself, I'm going to need to use a logarithm. The logarithm I want should match the base of the exponential. So what we'll do is we'll take log base 1 plus 0.06 over 4. And we'll do that to both sides. So exponent base cancels log base. So I'm left with just 4t over on this side. So divide both sides by 4. And that's what I would type into my calculator. So most of us, if you press the math button and then scroll down to the bottom, there's the log base option where you can type in any base to your logarithm, which is like super cool. Divide by 4. And we get that same thing after 11 years. So between year 11 and year 12, we would have, tipped up over $2,000. What do you guys feel on that?
So when it's asking that, we should do like years and integers.
Yeah, let me just double check and see what they how they answered this in the back or in the textbook. This is just like a textbook example problem. Scroll back and look at that real quick. Okay, so what they did it this way. So they graphed it to find that same 11 point whatever number. So they graphed and found the intersection, whatever. Same thing that we just did algebraically. Let's just take this for what it's worth. If I do that, if I do 4 times that number, that's about 47 quarters, and that's how they answered it. So again, how long, I think that this is a terribly worded question if they expect you to give an answer in quarters. Like, give me some kind of level of precision that you want me to do this.
Yeah.
Since it's a sequence and like, it doesn't really make sense to allow for non-integer values, which is why I would have just said after year 11 based on where this is located and but I don't know. So just do your best. I assume on the actual IB exam, they'll be a little bit more specific of how they want your answer, like round to the nearest number of quarters or something. But, all right, one just a couple more, more than I thought, examples. Says Samantha put $15K into the bank, earning 6% annual interest compounded monthly. How much interest will she have earned after 20 years? So how are we going to calculate that? Well, PRNT, right? Everybody agree? And then our interest then should be A of 12 minus A of 1. Or by A of 1, I really just mean like 15,000, right? Everybody's okay? I don't need to grind these out and get the numbers, do I? You go okay with just like the setup and you can calculator it okay yourselves? If you have an issue, holler at me and I'd be happy to do it. I just, you got it. Okay. Diego's got it at least. The rest of everybody is just staring at me blankly. You want to invest $1,000. What interest rate is required to make this investment grow to $2,000 in 10 years if interest is compounded quarterly? So this is P. This is like A sub 10. This is my T. That's my N. I'm looking for R as a variable, right? Quarterly. Um, 10 times 4. Everybody's okay with the setup? To solve this algebraically, what would I do? Divide by 1,000, right? Now to get rid of that exponent of 40, what do I have to do? Not a log.
Oh, so you like, was it square root?
Yeah, 40th root, right? Since it's an exponent, I'm canceling. Right? If my variable's in the exponent, then I need a log, right? My variable's not in the exponent, it's in the base of the exponential. That means I need a root. And then I'll subtract over the 1 and then multiply by the 4. And that ought to do her. So 4 times. How do I make a 40th root on my calculator?
Math.
Yeah, I can use math and then option 5 and type in like 40 for my root. The other option is you can use an exponent. So I know, so just under 7%. The other way I could do this, though, is if I wrote this as 2 to the 1 over 40. That's the same thing as a 40th root. So I could do it that way also, which is maybe a little like more button convenient because you never have to go through a menu to grab it. But either way of doing it is perfectly fine. You guys cool? Okay. Population tends to grow exponentially also, so we can use that same population or the same exponential model, or geometric sequence model to describe population. So P naught is like the initial population, R is like the rate of growth, and T is like a time. So the city of Baden in Lower Austria grows at an annual rate of 0.035%. The population of Baden in 1981 was 23,140. The estimate for the city's population in 2025 is what, 44 years? Everybody agree with that? P of 44 should be 23,140 times 1 plus, this is our R, obviously. Got to be careful, though. Got to convert that percentage to a decimal. We should be good there. Oh, oops, except not quite, right? What did I do wrong? This should be 1 in their formula. They just flat out have the wrong formula there. That should be to the 0. Instead of to the, if they want the 1 here, that needs to be the P1, not P0. That's a heck of a bad edit job there. Your formula's wrong in your textbook. Pretty upset. All right, last example. So depreciation tends to be exponential as well. So for example, you buy a car, it loses value. Well, you buy a new car, it loses value over time, right? Where does that model break? Eventually it might become a classic car and then starts gaining value again. But let's start here. A new car bought for 28,000 euros, depreciation each year by 17%. So again, it's going to work just like the population growth model, except instead of being plus, it's minus R. So here we'd have like 28,000, 1 minus 0.7 to the T. Again, notice because I'm using like V0, I dropped the minus 1. Everybody caught that? How much is the car worth after 5 years? Well, you know, just like plugging stuff in, right? Assuming the car is maintained properly, how many years will it be, or after how many years will it be worth 9,000? So we divide by, I don't know why I wrote it that way when I wrote it as 0.3 or 0.83 earlier. So we'll divide by 28,000, then do log base 0.83. Is it okay if I reduce 9,000 divided by 28,000, just 9 over 28? Again, on your calculator, you do math, and then you do that log base command down at the very bottom. If anybody doesn't have a calculator that does log base, holler at me and I'll show you how to do it without that command. But I think it seems like all of us have a new enough calculator that that's going to be the case. Use the graph of the sequence to display and discuss the depreciation pattern. Looks like it's exponentially decreasing, right? I don't know what else they're expecting to say there. Starts fast and then slows down. I don't know. It seems like a weird question to me. So that's the first 3 sections of chapter 3. without like giving you a discussion of like, what do we mean by characteristics? Yeah, I don't know.
Yeah.
All right. There's a million questions here. I don't know if I really want you to do all million of these things because like some of them, can be kind of annoying. Right? Do you guys want to be annoyed? Oh, thank you. Yeah, I think so too. All right, so let's see. Sure. .1 numbers 1 and 2. What do you think EOL stands for? Yeah, every other letter. So like if it's parts A, B, C, D, E, F or whatever, just do like every other one. Because like, I don't know, there's like H parts for something. It's like this is just, it's like the same thing over and over again. Like, what are we doing here? Yeah. Ah, boy, oh boy, oh boy.
Do you want so no water or shaving? Why?
Because I just love this sleep. It's so bad. It's still hurts.
That's just
Oh,
How
boy.
much hair do you have? I might not know.
I don't sleep. No, I just want
Okay, water is. Yeah, it's super quality knife.
I've done my
All right, let's see.
You started at midnight?
Started at 12:30.
You can use it actually at any speed you'd like.
Okay.
So like 1:45.
No, it was. Yeah. That's not spend an hour dry shaving that.
I was gonna take that one.
It's pretty good shit. You must be bad.
I had 100% and I sold in the last one. And then so that's just cheap. I did it like 4 times in a row. I did it twice or 3 times. I think I didn't even listen to anything. Like I just like put it in.
I'll be right now.
It took me allegedly 8 minutes to do it. I don't even remember the answer. I had a screenshot.
Well, I just still have this. Like, it's less suspicious if I get like a really good.
Like you got the money.
If I get a 25,
Did you say you were gonna do all those in
I'm just gonna share with it. You have to know.
According to this division. Maybe do a break and then come back, maybe a spring break. And there's like testing days and outer spring days.
So basically, that's cool.
Yeah, pretty much.
Also, I had to run across the school to get there.
You're always gets her name, but it doesn't get here on time. It's because she's in the healing.
But what time do you get to school?
I get here at like 7:30. And I leave
Oh, really?
7:39. That's what I usually do, but I can't.
I don't care because
It's probably why. It's just I get stuck in the parking lot. Because I'm here at like 7:30 and then sit in the line to get in until like 7.
Really?
It's because I have to turn left at the gate.
Let me get